Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, I'll help get you started with Chapter 4 in using this supplement. Effectively, this video is going to be about how to produce the tables and plots in the chapter for the Introduction to Modern Statistics, 2nd edition, Chapter 4. Okay, so let's just take a quick scroll through this chapter and get a sense of what we see, and then we'll dig into the code that produces these plots. I've taken out some of the formatting to make it more like what you would typically see or do in your own work. All right, so we are going to make these contingency tables where we have two categorical variables with different levels, and we're going to learn how to add these total lines as well. Bar plots, stacked bar plots, dodged, and I forget what this one's called. We'll do that one as well. This says standardized here. There's a certain name that has under the grammar of graphics, ggplot. There's these mosaic plots, which is a cool way of visualizing two or more levels of categorical data. Here we've got home ownership, where we have the width of each bar being the proportion, but when you combine that width with the vertical height of each color for the application type, then you've got areas that are proportional to the frequency of the table. All right, we've got row and column proportions. Okay, we'll find ways of doing that. We're going to look at the second data set about email, whether it's spam or not. And I will show you how to make a pie chart, but please never use one, because there's almost always like 99 point something percent, almost always a way to present data that's better. And typically that's a bar plot, and typically it's going to be ordered by the categories in terms of their height. That's called a Pareto chart when you have this decreasing relationship. Maybe it's this way for you guys. Okay, I'm going to show you these labels and stuff. These waffle charts are a cool way of indicating units. Okay, and then here we've got a categorical. Well, I think this might be comparing numerical data across groups. Okay, well, it's numeric. The group part is the categorical part. So we can have numeric data by group, and we can do histograms or box plots. I'll show you a couple ways of doing this. These ridge plots are sort of a newer phenomenon, maybe in the last 8 or 10 years. I find them to be interesting to look at, but distracting in terms of analysis because they overlap vertically. That's all I'll say there. Small multiples or faceting is something that I use all the time. I'll show you how to do that in a few different ways. Here's those ridge plots that are also faceted, I believe. And I think that's it. Okay, so those are the main plots that we're going to be looking at. So we'll go to the website. We will download this supplement. So I'm going to right click, save as, and this is a QMD file. It's the Quarto file. All right, just saving that to my computer. We'll open up RStudio. We'll open the file, navigate to the folder, and open the QMD. As with all my QMDs, the first thing you should do is set working directory to the source file location, and then render the document by clicking the render button above the source. All right, everything ran. It will have produced an HTML file, which I have in this other folder. All right. right, chapter 4, yep, here it is. Okay, and as you scroll through this, you'll see some of the tables and plots, though they will look different. Mosaic plots, there's the pie and bar chart, there's the waffle plot, okay, etc. Okay, so everything's here. My goal for you in this video is to be able to do a couple things. First is look at someone else's code and interrogate the code so that you learn about what it's doing. That's how you will develop some of your programming skills. The second thing is to be able to look up the help and write some of this code by yourself. All right, so let's scroll down. What we're going to do is basically run each of these chunks at a time and then edit the code and look at what happens both in the console with the data and in the plot window for the plots. All right, so there are a number of packages. I've provided some comments about what each package does. The main ones here, tidyverse, of course, is for formatting data and plotting it. The open intro is the package that goes along with the book that includes the data sets. Patchwork is a package that allows you to arrange your plots in grid format. So if you have multiple ggplot objects, you can arrange them in a single figure. Cable extra, a cable is a knitter, that's where the K comes from. Table, that's where the able comes from. So a cable is a knitter table. A knitter table is a table that is produced by knitter in R Markdown file, which Quarto documents are very similar to. Janitor is only being used to calculate the table totals, but it does lots of other cool stuff. GG Mosaic is for the mosaic plot. GG Repel is when you have different labels that are being plotted. Repel, it makes the labels move away from each other so that the text does not overlap, so it's easier to read those. Then we have waffle plots in this waffle package. Now, typically you would do something like an install packages with the package name, but in this case there's multiple versions of this package, and the old version that is on CRAN, which you'd get by running install packages, doesn't have the functionality that we need. That comes from the current GitHub version, which you can install using the remotes install GitHub function. Scales allows you to modify the scales of plots and other things, but mostly for plots, like if you had dollar signs or you needed time or scientific notation or some other type of formatting, scales is a great way of doing that. And then the GG ridges makes those density ridge plots. All right, let's make sure that we've run that. So all the packages are available to us. All right. The first set of plots, in fact, maybe I will bounce back and forth a little bit. All right, we'll go up to the top of the chapter, okay, chapter 4. I'm going to page down, and the first set of plots or objects we're going to create are this table and these bar plots. So the data set we're using is coming from the open intro package. So open intro double colon indicates that the package is the open intro, and then the object coming from that, which usually is a function, but in this case it's a data set, is called loans full schema. And if we look at the structure of that data set, we see that it has 10,000 rows, 55 columns, 55 variables, and those are all the variable names with their variable types and their first few observations for each one. Okay, this piece of code takes the variable home ownership, this one here, home ownership, and the first thing it does is, well, okay, there's a couple things here. Application type, it changes that to be a character string, and then it removes anything where application type is not equal, it keeps, the filter keeps where application type is not equal to blank, which means it removes the blanks. Okay, so then we've got observations where application type is not blank. Now, I believe that that actually doesn't change anything. Oh yeah, this is sort of what I want to show you. So after it does all this stuff, it creates this loans data set. So let's just do this. We take each step and print that out to the console. So I'm going to print out the loans full schema. Okay, this is, let me make this window a little bit bigger. All right, there we go. So it prints the first 10 rows for however many variables will fit on the screen, and then it lists the remaining variables below. I need to move my camera for a second because it's obscuring my ability to see the screen. Okay, that's better. All right, then, so it takes the data set and then it pipes that to the mutate function, and in there it changes application type to a character string. So let's take a quick peek at the application type. Okay, and press enter. It is I can tell right now that it's a factor variable because it has levels, and if you make it go to as character, it'll just be a character string. So if we take this here, in fact, do we see it? Application type. I'm trying to find it in the list of variables. You're all seeing it and yelling at me through the computer screen. I don't see it. Why don't I see it? Application type. Okay, maybe it's near the end. Well, there's 55 variables. Where is application type? Oh, here it is. It's down at column 40. So, okay, it's just not displaying. So anyway, this is going to create that, make that variable a character string instead. In fact, if we do a pull application type, and yeah, and then just print it, you can see down here there's no more factor. Everything is just in quotes as a character string. So it did what we thought it was going to do. Filter will keep anything where, and notice there's no application types here that are blank. They all are either joint or individual. So this filter doesn't actually change anything. And then finally, it's going to convert home ownership, the home ownership variable, so loans full schema, home ownership. These are all in caps right now, capital letters, and 2 lower converts capital letters to lowercase letters. And then it's going to refactor the home ownership so that rent is the first one, rent, mortgage, and then own. And it's also going to re-level the application type joint and individual. And that's going to create a new data set called loans. All right, which also, unfortunately, has too many variables still. Probably something that would be nice to do at this point is also just select the variables that we're going to use. I'm going to, so in that case, it's going to be select. And we're going to select home ownership and application type. And that's going to give us a data set that is just what we want. So we've got 2 factor variables, everything's lowercase. We've got those 2 data sets. In a moment, we'll find out whether we need other variables, and if we do, we'll just add those in. But it's better than a 55 column data set. All right, so we can look at the structure of that data set. Okay, it's got 2 factor variables. All right, so the main thing that I'm going to point out over and over again is that you can go through a piece of code and run one step at a time, right? Basically from the beginning up to, but not including, the next pipe. And you'll see what it has done. And this is how you will develop your own pipelines for data sets. Okay, so here we're going to create this other data set, loans, individual, rent. We're going to start with loans, and we're going to filter where it only has application type individual and home ownership rent. So if we do that part, we see it's a data set, has 3,400, almost 3,500 observations, and it's only those observations where we have rent and individual. And if you pipe that to n row, that's the number of rows. So we're going to print that out, and we can print out the number. Okay, that's all that does. All right, let's get into tables. So the main function that's going to do the work for us is count. So we'll start with the loans data set. We know what that looks like. If you highlight it and press Control Enter, it submits it down to the console. Okay, so we've got loans. First we're going to count up by these two variables how many rows there are. Okay, so if you do that, we now have these two columns. Application type, that's the first variable. So that's the first level of the hierarchy is application type. There we have 3 lines for joint and 3 lines for individual. Then the second variable to count by is home ownership. That's here, and that has 1 row for each. Rent, mortgage, own within joint, and then rent, mortgage, own within individual. And n is the frequency, how many rows there were. So we already have our table. We're done. The rest of it is all styling. Okay. The next part, pivot wider, is a way to take long format data where there's 1 row for each observation and make it wide where there's 1 row for each category of data, maybe, and then there are separate columns for different subcategories of that data. So what we're going to do is we're going to take the names from the home ownership column, that's this home ownership column, and we're going to take the values from n right here. So we'll have a row for each application type, we'll have a column for each home ownership, and in the body of the table where the values are, those are these values n. So let's run those 3 lines of code. Okay, good. Application type, each row, joint and individual, and then we've got columns, rent, mortgage, and own. Those come from these names, right? It was names from home ownership. And then values from the n, the 362 was for the row joint and rent, so we have joint and rent. Okay, so it's a way of restructuring the data. You can pivot to wider, or you can pivot longer. Go from wide to long format. All right, then we're selecting just these columns. Application type, rent, mortgage, own. You know, our data already has just those. Then the rest is just adding stuff. Adorn totals comes from the janitor package. It will, by row and column, give you totals by row and totals by column. Okay, though I think these labels are actually total across rows, and total across downward across columns. Okay, then KBL is a formatting for tables. It actually takes the table and it puts it up here in the viewer. Okay, so here's a table the way you might want it to display in an HTML file. Okay, then we've got cable styling. So Bootstrap is I think it's a formatting syntax for tables, and this is doing striped and condensed. And LaTeX is if you were to render this to a PDF file and it was to create a table in the format of LaTeX, which is another typesetting program. I think those options don't apply to us in this case because we're making an HTML table, but here we've run that and it has striped, has the alternating grid lines or grid colors. All right, then we've got add header above. I'm not sure what this does. Let's just run it and see. Aha. So home ownership is a header above, and notice that it is a line over these 3 columns. So the first column, there's nothing. The next 3 columns, there's home ownership. And then the last column, there's nothing. Okay, that's the way that's worked. And then column spec looks like this is setting equal width for each column. There it is. And 6EM. So EM and EN are different width measurements. EM is the width of one lowercase letter m. And this is 6 of those. So if you press the letter M 6 times, that's what you should get. This looks like it is almost like, well, it does not look like it's 6M either between columns or within a column. So I'm not quite sure what it's actually doing. Anyway, so that is some additional formatting. You know, if it was just me, I would probably stop there. For most of the work that I do, and we can comment out these lines. Control Shift C would do it as well. Let's try it. Control Shift C. Hey, why didn't it do it? Control Shift C. There we go. So that's enough for me. I've got my table and my totals. Okay. Rarely do I need to make presentation style quality tables, and often even then this type of table is sufficient for that. Okay, let's go back to the website. So that's the table that we made right there. I'm going to skip the next table and let's focus on these bar plots. All right, so what do we have in this bar plot? We've got frequencies on the y-axis. We have home ownership categories on the x-axis. So we need to assign the home ownership variable to the x-axis and then plot a bar plot. And it will automatically count the frequencies. In the second case, we're actually going to calculate the proportions. And there's multiple ways of doing that. We'll see at least one of them. So we start with ggplot. We put in the data set and we're going to assign home ownership to the x-axis. Okay. In fact, let's just run that and see what we get. We get a plot where home ownership is on the x-axis. There's nothing in the body of the plot because we haven't specified a geometric object to plot. So to that plot we're going to add a geom bar. So let's run that. So now we've got bars and the y-axis automatically has become the count. And then we can label things. Compared to the code in the book, I've added a title, which will be counts, and then labeled the x and y axes. Okay. Yeah, the only difference here is that we've got capital letters. So the plot is not really going to change very much. The last thing is we're going to assign this plot to an object called pcount, because we're going to arrange this plot with other plots in a figure in a moment. All right. The next thing we're doing is we're going to plot the proportions. So let's see what it's like to calculate these proportions. I've pulled out a piece of code here down below. So we're starting with the loans. We're going to count up home ownership. Okay, so that just looks like this. So for each home ownership, we've counted how many rows. And then we're going to create a new variable by mutating called proportion, which is n, which is the name of the column, divided by the sum of n, by the total, right? So n divided by the total is the proportion. So we've created a new variable, and it's these proportions. And it's these proportions now that we're going to plot. All right. So notice before we had geom bar. Coming up, we're going to do geom call, and we can look for help on that. It shares a help window with, or a help entry with geom bar. It says the geom bar, well, somewhere in here, geom bar and geom call. Okay, geom bar basically counts the number of cases at each x position. Geom call, like for columns, like bars or columns, leaves the data as it is. So whatever value you put in your y-axis, it is going to plot that height up for the bars. All right. So we start by doing these 3 steps. where we create that table that we see below. Then we're going to assign to the x-axis home ownership and to the y-axis proportion right here. And then we're going to do a geom call. So let's just take a look at what that looks like. Okay. The variable name proportion is on the y-axis because that's the variable name in the data set. Otherwise, you know, the only thing that changed really between the counts and the proportions is the y-axis. All right, so then the rest puts labels on it, and then the patchwork package allows you to take different ggplots and put them together in different ways to make a grid. So notice count plus proportion laid them out along a single row. I should just show you a couple things here. If we did a divide, that's going to put one over the other. Okay, so now we've got counts over proportions. And there's lots of different ways of laying out plots. So I recommend, let's see, this is R patchwork. Okay, good. Here is the primary page for patchwork, and under guides, controlling layout, will show you lots of ways of, you know, controlling the widths and the heights and so on in arranging different plots. Okay. All right. So let's go back to our chapter. Let's visualize two categorical variables. Okay, I'm going to start going a little faster because I've sort of walked you through a lot of the stuff I want you to know already. Here we've got bar plots, but notice we have two things that we're plotting. We've got, in fact, let's go over and look at this plot first. I'll make this a little bit bigger. Now we have, notice we've got a legend which has the application types. So blue is joint, yellow is individual. Those are custom colors for this textbook, and I've removed the code that makes those custom colors to simplify the ideas. Okay, so we wanted to create this first plot. We've got home ownership, which is on the x-axis, and then we've got these colors for the different application types, and the bars are stacked up. I'm going to show you the right way to do it, and then I'm going to show you what I often do first, and then I remember what the right thing is. All right, so we're going to start with the ggplot of the loans data set. We are assigning home ownership to the x-axis and application type to the fill color. So fill is the color of of how the shape is filled. Okay, let's just run that part. It's not going to be very interesting. We only see the x-axis because we haven't filled anything, because we haven't plotted any geometric objects. Once we add the geom bar, now we get the fill color. The red and blue are the default colors for two categories, and we get the counts on the y-axis. Now I'll show you what I usually do first, because I want color. But color for bar plots is actually just the border color. Okay, so it's maybe a little bit hard to see, but there's a red outline and there's a cyan or blue outline on the outside of these boxes. What we want is the fill to be the application type. I'll show you one more thing. If we did a color equals black, what would that look like? Well, it would put black borders around the outside. Okay, I think even if we were to do line type equals, say, 2, which is, or you can say dashed. How about that? I think it's that line type that is colored and is also being dashed. Okay, so you end up with like tons of ways of formatting this stuff. I don't think I want to go into more detail than, you know what, I'll do one more detail. Okay, so application type we could assign as an aesthetic to line type. Okay, line type is it doesn't need to be dashed or solid. It could be different depending on the group. And this may be hard to see, but these top red ones, which is the first category of joint, is line type 1, which is a solid line. Line type 2 is this dotted line, and that's what's around the blue boxes. Okay, so all of the visual aesthetics of a plot can be encoded, or you can take your variables and you can encode those encode them as visual attributes, including line type and line thickness. Right, so you could even do like width. I'm not sure that this is going to work. Actually, let's see if the width of the line. So this is sort of a way to start experimenting. I don't think I see a difference between these two. Or line thickness. Oh, so how about size? I think it's size, actually. I may have, yeah, there we go. Whew, that is ugly. But we definitely have like line size 1 for these, for the solid ones going around the red boxes. Size 1 is actually a little bit big. The default line sizes are smaller, like 0.2 or 0.3. And here's a line size of 2 for this dotted or dashed line now. Okay, so that is the sort of things you can play with. All right. All right, I'm going to remove the color. If you remove the color of the lines, I think you don't really see anything. Okay, yeah. So, because you're not plotting them. All right, the last part of this is that we're labeling the x-axis, the y-axis, and this other attribute called fill. Okay, so right now the fill label is application_type. It's what's being labeled in the legend. And now we've got a new variable or a new name, application type. Now if you didn't have enough room there, we can put a line return. /n is for new line. And we don't want a space after our n, so I'm going to remove that. And now it's a little bit hard to read, but it's application, new line, and then the word type. So let's take a look at that. Okay, now we've got application type over here. So lots of, you've got full control over these things. So let's take, okay, so that's our stacked bar plot, right? It's stacked because the different groups are stacked on top of each other. It makes it really hard to say like how many joint applications are for mortgages. Well, you've got to take the difference between the top and the bottom. Okay, so I don't use stacked bar plots except for sort of special circumstances. So this dodged bar plot is going to do the same thing, except we've got this position equal dodge within the bars. Okay, everything else is identical. So now the bars are side by side. Okay, nothing more really to say there. Let's see, so standardized. All right, so this position fill is what it fills the vertical space within each plot. This fill is not the same as the fill color. Sorry. But the position fill is that we're filling the vertical space, so the y-axis is going from 0 to 1. The axis is now called proportion, and it's a stacked bar plot, but everything's normalized so that the colors now represent proportions within each group. Okay. All right, so then this is pretty cool. So I'm going to show you, we're going to start with this. We're going to add these 3 plots together. You should start making predictions about what are you going to see. Stacked plus dodged plus standardized, 3 plots added together is going to put 3 across in the plot area. I'll make this a little bigger. Okay. Now plus guide area does something special. All of these 3 guides are the same, except I've renamed this fill. I actually don't know what's going to happen when we do that. Okay, it has made one more place for the guide. It is effectively made 4 locations, and one is going to be for the guide. The guide is this legend, and we're eventually going to put the legend there. The plot annotation gives us labels in the top corner, A, B, C, and we would have a 4th one, D, but the legend doesn't get its own plot label. And then plot label or plot layout guides collect. We're going to collect the guides from all of the 3 positions and put them in the guides area. Now, do you know why we got 2 separate ones? That's because we changed the title of one, and so it recognizes that these are different. But if we go back in and reset that one to be have a space just like the other 3 or the other 2 have, and run all that, we'll end up with one common legend in the corner. Beautiful. Now, one thing that surprised me just now is that when you add these together, notice it made a 2x2 grid and not just one continuous set in rows. Okay, this plot, these plus signs are actually what would be a bit like a facet wrap, where it goes across rows and then it wraps to the next row and so on to make the best use of the space. I wonder if we change the shape of this plot window, whether we can make it come out differently. Well, I made it as wide as I could. Okay, it's just coming out 2x2. So if you wanted them to look different, what could you do? We could go to control layouts, and there's all this stuff about designing a layout where the different plots are going to go. You would only use this in very specialized situations, but the main thing we want to do, say, is plot layout. Let's scroll up and find, here we go, plot layout. I'll make this a little bit bigger. You can specify the number of rows and the number of columns. So let's do this for this plot. So we'll add, so we'll do the number of rows equals 1, and once you've specified that, you don't need to specify the number of columns. So let's see what this looks like. Oh, that is not the plot that we're working on. Guys, you gotta catch my mistakes. All right, it's this one here. All right, so here we've made where the plots are all in one row. Okay, we could also do the number of rows is 4. Okay, so there's 1, 2, 3, and the 4th row has the guide on it. We could do number of rows equals 3. Okay, I'm not quite sure what that's going to look like. 1, 2, 3, 4, and then we've got 2 open spaces at the bottom. Okay, so you've got a lot of control over what you're going to see. You might even do something like number of rows is 2, number of columns is 3, because you're going to edit this. You're going to pull this into Adobe Illustrator or Inkscape or something and modify the vector formatted graphic, and you might add your own graphics in there as well. Okay, so all right, how are we doing? We're at 38 minutes. All right, let's go back to the book. I really like mosaic plots. It's a way of displaying visually how big categories are in like a visual table. Okay. All right. So let's start with ggplot, and we just put in the data set. So we get nothing. Then we're going to use the geomosaic, and we're going to encode the homeownership to the x-axis. Product, I don't know what it does, but it comes from the mosaic package. It says it's a wrapper for a list, and it looks like you're just going to put in the variables in there in order to make the geomosaic plot. That's as much information as what's in there. So let's go ahead and do just that much. Okay, there's our plot. We're done. The rest is labeling the x and y axes. So it's going to take away, actually there's no label on the y-axis, but it is setting that to blank. Okay, so we'll do that much. It's also labeling the x-axis with a capital H, home ownership. So we see the capital H appear. And then there are ways of controlling the theme, basically the elements of the plot. Okay, this is going to be the axis title y. So the title for the y-axis is going to be a blank. Element blank is a way of basically saying it's a null. There's nothing there. The text for the axis text, that's like would be words and stuff. That's going to be blank. And then even the tick marks, these little black dashes next to the numbers, those are going to be blank as well. Okay. And because there's now nothing over there, the plot fills the space. Okay. I think those are unimportant details, but at least I've shown them to you. In the second plot, we have two variables. We have the x-axis, but then we also are filling the we're changing the color based on application type. So let's see just what that part does. There's our default, okay, and it automatically labels the y-axis. We have colors for the fill, and it's labeled the axis sort of by where the colors are. And we can update the labels for the x and y axis. Okay, that's fine. Now guides fill equals false should take away, I think, the legend. Let's see. Yes. Okay. The legend was there only for the fill variable, the application type. And when you said it was false, we've removed that legend. Okay. And then the last part just puts these two plots together, side by side. Very good. All right. This, I don't know. What's the difference between these two? I think we've just swapped axes. Here we have home ownership on the x-axis, and down here we have home ownership on the y-axis. So it's the same plot. Now, this is an important point. These are conditional relationships. For example, within mortgage, what proportion are joint? Okay, that's what's displayed in each of these vertical bars. And then along the x-axis, you can say something about what proportion of home ownership is rent, mortgage, or own. But it's harder to get at individual and joint along the x-axis. So there's a hierarchy to these relationships. Let me show you. So this one just swaps these two variables. So we'll do that. Okay. Now I need to try to remember how to swap axes. So give me a second to look at my. There we go. Okay. So if you wanted to swap the coordinate axes, x and y, you can do coord flip. Let's see. Aha. So now, right, so we started with application type on the x, and when we flip the axes, application type is now on the y. And the bars, the stacked bars, are now along rows where they originally were along columns. Okay? So that may be a handy, handy for you. There's one more thing I want to show you. I think this is it. Sometimes the plot is in like the wrong order. It goes, in this case it's going, well, I think it's going rent, mortgage, own, but I think that was the order. So here I'm going to try to rescale the y-axis, but I'm actually a little bit confused because, okay, this is the original variable, because the coordinate flip, I think, flips the axis visually, but the x and y axis are still their original names. So anyway, let's let's run this much. Let's run this much. Okay. This is where we're starting. Oh, boo. I have to start from the ggplot loans. Okay. So we've got, this is our original plot. Now we're going to reverse. So for the y-axis, we're going to reverse the limits. That means we're basically going to flip the axis. So right now, own is at the top, rent is at the bottom. If we run this, excuse me, it didn't like that. Map discrete. Maybe this is not a discrete axis. Y. Let's try y continuous. Okay. I don't know how the axis works for the mosaic plot, so I can't do that. But the basic idea of what I did will work for other types of plots. Okay. All right, let's continue as I get a drink of water. All right, so this next part is just showing how to put totals into tables with row and column proportions. We've seen, I guess we've seen this already because we've seen the adorned totals. So I'm going to skip this. All right. And we're going to look at this new data set about emails. Okay, and I think the main thing here is whether an email is labeled as spam or not. Password. All right, so here's the data set. The email data can be found there, and they make a little table where it's just a two-way table of spam versus the type of text or something. Let's see. We're doing some labeling. Okay, this is sort of handy. So we're starting with the email data set. That's email. We're going to create new variables. And so right now we have a format variable, which doesn't show up down here. Where is format? Format. Here it is. It's a factor variable with zeros and ones. And we also have a spam variable here at the top, which also is zeros and ones. So if, zeros and ones is not informative, we really need a variable that has the labels associated with the categorical levels. So here, if the if-else statement, let's look at the help for that. So if-else statement does basically there's three arguments. So if the condition, the first argument, is true, then you're going to return the value in the second position. Otherwise, you're going to return the value from the third position. Okay? So if format is equal to 0, you're going to return the word text. Otherwise, you're going to return the value HTML. That's how that works. So let's run that part. And I can already see, it's sort of annoying to have tons of stuff here, but we do see the spam, at least the spam column, started off as zeros and ones, and now the spam column has the word not spam. Whereas wherever spam was not equal to 0, it would be labeled spam. Okay, so without selecting only the rows we're looking at, let me continue. So we're going to count by spam and format. That will create a small table of just those two variables with the frequencies. Okay, most of the emails were not spam in HTML format and also not spam in text format. And then, a sizable proportion still were spam. And there's a lot more text spam proportionally than HTML spam. So that's something I can see already. The rest of this, let's just run it and it will create our table in the viewer window. Okay. All right, so that table should be the same as this one. Let's keep going. Pie charts. Never make a pie chart. Always make a bar plot. All right, let's go down there. A pie chart. There is a very interesting way to look at a pie chart, which is a pie chart is a stacked bar chart in polar coordinates. Right, polar coordinates go around the origin, like the North Pole. You know, when you think of calculating angles in radians or even degrees, like you start at the origin, the x-axis, the positive x-axis, and you go up and around for 2 pi radians. So polar coordinates is a way to represent a bar plot, a pie chart. And in fact, they make it hard for you to make a pie chart in ggplot, because why are you doing that? Okay, so anyway, let's take a look at this plot here. We're going to start with loans, the loans data set. Oh, we're going sort of back to the original data set, not the email. And we're going to mutate factor in freak. So let's take a look at what that is. I don't see any difference between that. So let's take a quick peek at this function. It comes from the 4cats package, which is ways of dealing with factor variables. So in freak, factor in freak, by the number of observations within each level. So this is a way of reordering factor levels. Okay? This means that this, okay, let me show you this. Okay, so let's look at loans, and we'll look at the structure of loans. All right. So it has 2 levels. Joint is first, and then, oh, sorry, this is home ownership. Home ownership starts with rent, mortgage, and then own. Those are the 3 levels. In fact, maybe it's a little easier for me to do home ownership. And we'll look at the levels of that factor. Okay, that is the order of those levels. If we mutate that variable and say pull home ownership, and then look at the levels, now we've got mortgage first, rent second, and own last. So it's swapped rent and mortgage because more people have a mortgage than rent. All right, in fact, I'm going to make this plot in 2 different ways. Let's first not sort that variable and create the plot. Rent, mortgage, own, that's the order of the variables, but if you put that mutate back, you reorder those 2 columns. Okay? Now it didn't change the colors, or rather the order of the colors, because the default order of the colors are red, green, blue for the first, if you have 3 variables. But it did definitely change the order of the variable, the levels along the axis. All right. I'm not going to go into the pie chart. Okay. So that's one, and here's another one. I'll just show you, I will show you this one because it does the geom text repel, which is pretty cool. So let's see what we're doing. We've got loans by grade. Oh, you know what? I have to go back. We're using a new variable. Remember, I selected in the loans data set to keep only those variables that we're using a lot. Okay, here we go. No, almost. Loans. Oh, we're getting close. Okay, so this other variable is grade. So all I'm doing is creating the data set again, but I'm selecting grade. So now grade is a column in my data set. Okay. I remembered the line number that I started at, around 300. Here we go. So all we're doing the pie chart for is to look at the repel. So we're going to start with the data set. We're going to count by grade. Okay, we've got A, B, C, D, E, F, G, 7 categories. And these are not strictly decreasing. The highest number is B, followed by C, and then A. But the grades have an order to them, right? This is an ordinal variable, an ordered categorical variable. So we probably want to keep the letters in order. All right, so then we're going to count, and then we're going to mutate. So cum sum is the cumulative sum. Text y, cumulative sum minus n.5. Oh, this is a way of specifying the positions all around a circle. So 1230 is the halfway point of this number. 3978 is the halfway point of 3000 after adding 2459. So anyway, this is a clever way of finding the midpoint of these numbers. In fact, let me show you one more thing. Let's just look at the cumulative sum. All right, so the cumulative sum, the first one, the cumulative sum is just the first value, and then we have the second value, and the third, the first two values, the first three values, the first four values, just adding them up as we go. So the cumulative, so the number on the right is basically starting from the value from the previous bar, add half of the current bar, and that is the midpoint. So that's the value of the previous one, or actually this value of the current one, current cumulative sum. In this case, we're subtracting off half of the current value. Okay, so that's pretty clever. So to that, now we're going to put that into a plot. Looks awesome. We've got x-axis is blank. Fill is the grade. So basically we have the colors. The fill colors are going to be grade, but we don't have anything on the x-axis. And then the y variable is the letter, the n, the frequency. Okay, and we have n here, which is counting up. Then we're going to do a bar plot. And it's a stacked bar plot. Reverse equals true, so that's reversed the categories so that the first one is at the bottom. I think that if we did this, let me just do it down here. If we didn't do reverse equals true, I think it puts the red on the top. But reverse equals true, put the red on the bottom. So we're counting up A, B, C up toward the top. Then the text repel, for me, that's the cool part. So text repel, we're putting the x value at 1.4. I don't know. There isn't really a scale here, so I'm not quite sure what that is, but it's off to the side. The label is what grade it is. So in that data set here, grade are these letters. So that is the label that's being positioned. The y position is this text y. So that's the position. So that they would be hitting the midpoint of each of those. Now notice up here at the top, E, F, G, those would have laid on top of each other if the line was completely horizontal. But the repel made them move around. Let's see, nudge X is a way of shifting it in along the x-axis. Segment size, I think, is the line segments, these black lines. Okay. I do want to show you, I think, what a basic label would look like. So if we did just geom text and you did, I think, label equals grade. Okay. So I'm just doing that part. It would, I think, hold on a second. Aesthetic. We have to, the aesthetic, see down here I have object grade not found because it wasn't looking for grade inside of the data set. It looks for the grade inside the data set when it's an aesthetic. So that's basically the aesthetic is saying look in the data set for this. All right, so here are the labels. Those don't look very good. Oh, but I probably need to do something like put these positions in here. Sure. I mean, x equals 1.4 isn't really an aesthetic, because it's not a variable coming from the data set, but the text y certainly is. Okay, so we're specifying the positions. There we go. A, B, C, D. So they're lined up, but they're laying on top of each other. So that's not great. So if we repel them now, right? Let's just do that part without the nudge and the segment size. Now you can see that they've repelled, but it's hard to see like E, F, and G, like what color bands are they referring to. So that's where this segment is helpful. Okay, so anyway, that's just some stuff. All right, then the fancy thing happens. We're gonna convert the y-axis to the theta value, the angle in polar coordinates. This is what's going to wrap the y-axis around, and it starts at the top and it goes clockwise. So that's not how normal polar coordinates start, but it is how clocks work, and everyone reads a clock. So that's why that is the default. And then theme void is going to take away the background colors. Boom. And then we're going to add a title called loan grade. Okay. So anyway, that's how it's constructed. I hope you learned some things from there. All right, waffle charts. We're really moving. Is that true? Now we're at an hour. All right, waffle charts are pretty cool. So we're visualizing categorical data here. Notice that things are basically rounded to units. In this case, each row has 10 in them and each column has 10. So you can count up the proportion by just counting up, how many blocks there are. So there's clearly 39 of these rents. There's 48 of the mortgages, and there's 13 of the own. So pretty quickly you can sort of get the values approximately. Let's take a look at that plot. I think I'm going to probably go quickly through this one because we've seen a lot of this stuff. The only new part here is coordinate equal. So let's take a look at that. So we've got loans of home ownership. Okay, we've seen this count table before. We're going to assign the fill colors to home ownership and the values to N. So the values are going to be what is in the geom waffle. That's a special aesthetic which usually isn't used, but is required by geom waffle. So let's run just the geom waffle. Okay, there's a basic plot. You could be done at this point. The labs are just putting in labels. Okay. In particular, it takes away the fill color label and it put a title up top. The coordinate equal, I use this a lot when the x-axis and the y-axis are on the identical scale, and the relationship like a one-to-one line, like x equals y, is important. I always do coordinate equal so that it squares it up. So the units go from 0 to 10 on the x, 0 to 10 on the y, and they take up the same amount of space on the screen. Okay, theme enhanced waffle. Ooh, this is going to look awesome. Well, it's enhanced. And then we're going to put the legend on the bottom. That's how that does. Okay, we still have these tick marks. I'm not sure I am in love with those tick marks, but okay, that's the basic idea. Let's see if there's anything else over here. No. Okay, so let's take a quick peek at this home ownership table, and let's pass this to mutate and calculate a proportion is equal to n divided by the sum of n. Okay, so there's our table. Notice that these proportions are not in equal, hundredths, right? Because there's 100 squares on the right. So there's some rounding that's happening. We've got the rent is 38.6. If you round that to 39, there's 39 red blocks. Okay, the blue is 13.5, and it's being rounded to 13 blocks. Okay, so maybe that 13 is like 13, like 0.13, I don't know, something less than 5 that rounded up to 5. So that's what's happening there. These boxes are being rounded. Okay, that answers my question. Comparing numerical data across groups. All right, I'm going to skip a little bit. The basic idea is like make a histogram, but then set the color to be a categorical variable, and then it creates two separate plots. In a moment, I'm going to see whether I like this plot or not, but I don't think I do. Let's start with county. Okay, there's a data set. I'm just going to make sure we did modify county, so I better run all this code here. You can press the play button in a code chunk to run the whole thing. All right, so we're starting with county. It is a data set with 3,000 observation and 17 variables. We're looking at, it's like we're selecting a subset of the columns. We're filtering wherever the pop change is not an NA. So if there's a NA in here, a value that's not available, NA, not available, we're going to remove any rows with not availables. Then we're going to group by the population change 2 levels. That's one of these other columns down here. Slice sample 5. Okay, this is getting sort of sophisticated. So let's run this much. Okay, that's the full data set. Let me make a little more space down below. The data have been selected, just these columns, and it's been filtered, so we have no NAs in this column, and we've grouped the data so that any operations we do, like sampling or mutating or summarizing, is done by group. The slice sample is basically taking a sample every 5 rows. So you're counting down. In fact, let's see what that looks like. Group by slice sample 10 by 5. How do we have only 10 rows when we started with that many rows? Okay, I'm pretty sure I understand slice sample. Let's look at the help, because I always do. Slice sample randomly selects rows. Okay, sorry. I was thinking of something else where you slice at every so many. I think there's a way to do that as well. Okay, but anyway, slice sample, we're going to randomly select. This says 5 rows, but we've grouped by the pop change 2 levels. So here's population change 2 levels. We have 5 samples where there's gain, and we have 5 samples where there's no gain. Okay? So then we're going to arrange, that sorts the rows by the 2 levels, and then by the state, and then by the name. So let's get that sorting done. Okay, so we've sorted by this variable first, and then state, and we've got 2 Arkansas, and then we've sorted then within Arkansas by name. So Boone is before Perry. Same, that's the only conflict. Okay, and then we're going to do some renaming. Name is actually going to be the county. Lowercase state is going to be capital state. Okay, and if you've got special characters in your variable name, you can begin and end them with the left tick mark. So that's what's happening here. Pop change is going to be population change with spaces and a % inside parentheses. Okay, so let's run all of that, and that is our table. Okay, why are we doing all that? I think we're making this table here. Notice that the column headers have those nice labels now. Okay, this is something that we can do because the data is in a tibble rather than a data frame, because we're using tidyverse. Okay, and then there is some additional formatting here which I've just commented out because it makes it look nice for the HTML, but it's sort of not important for us at the moment. All right, the next part is making these histograms. Okay, I'm going to show you, let's do one, and then I'm going to show you what I would do differently. So we've got this county data set. We're going back to the original, where again we're going to drop any rows with NAs as population change. Then we're going to assign as the x-axis the median household income, and the fill color is going to be that pop change 2 levels about gain and no gain. I don't know what those are, but anyway, so this much so far has given us an x-axis. Then we're going to make a histogram where the bin width is $500. Okay, then this is beautiful. Okay, so we're going to scale the x-axis. Look at this, like 5e plus 0.4. So 5 times 10 to the 4. So this line is $50,000. Okay, this line is 1 times 10 to the 5. So that is a 1 with 5 zeros. That is $100,000. So those are hard to read. So instead, we're going to scale the x-axis, and what we're going to do is change the labels to be in dollar format. This is something I love. $50,000 to $100,000. Now it's readable for humans. And usually your audience is going to be humans. Okay, so there's the final plot. Now, this plot, in my opinion, is a bit deceptive because you can't really tell the difference between gain and no gain, or you don't really know what the distribution of gain looks like because it's stacked on top of the no gain blue. So let me show you faceting. Instead of assigning this to the two groups to fill, what I would usually do is facet. Let's just do grid. Facet grid. We want each row to be a different pop change level, and then we don't want any columns, so we just put rows tilde columns, and we're just going to put a period as a placeholder. This will create 2 rows, one with gain, one with no gain. And the reason why you would want them to be rows is because they share a common x-axis. Okay, and then once you have that, I wouldn't fill. I wouldn't assign a color to fill because color is sort of double encoding. We already have labeled the facets or the small multiple panels. We don't also need to put colors in there. And then we also have this alpha level equal to 1/2. That is definitely not important. It's like creating a light shading here, so we can give it the full darkness. Yeah, that's probably the plot that I would create. Okay. All right, let's go back here. Here they're just making a box plot, but the same idea. Okay, I'm going to skip past there. And let's look at what is happening next. Oh, this is a thing I don't like. So these are a ridge plot. They're density curves, but one density curve is allowed to overlap the plot area of another density curve. Okay. There are scenarios where this sort of both looks cool and gives you more information, or gives you information also, but I feel like this is a distraction. Okay, geom density ridges is all that's happening here, new from what we've seen before. Okay, so there it is. Let's see what else. Okay, so this is now faceting or small multiples. I just did one example of this, right? So there are 2 facet commands. Let's do facet. Let's look for facet grid. Here's facet grid, and there's also facet wrap. Facet grid is nice because you can control like how your data are plotted on the x-axis and on the y-axis. Whereas facet wrap is handy if you just have one variable, many levels, and you just want to plot all of them row by row. All right, so let's take maybe look. Let's start by just looking at this and see what we get. Okay, that only has 2 levels. Let's look at this. Okay, so this has this. I think there's one thing here that's happening that's nice. Yes, it's using labeler. Okay, let me talk through this. So we've got a data set. We're doing some filtering and renaming. That's not the interesting part. We're making histograms, okay? And we've done fill equals pop change. Okay, so we've got pop changes red and blue, and we've got our histograms. Next, oh, this is not an important thing. Scale fill, that is just changing the colors. I'm going to remove that. Okay. Scale x continuous, okay, we're labeling it with dollars. Okay, we did that before. Now, facet grid, oh, interesting. Pop change metro is the variable that it's doing the grids. Pop change, oh, it's because they didn't put spaces. Pop change tilde metro. So pop change is on the rows, metro is on the columns. And the default version of that looks like this, where you just have no and yes, and gain and no gain. Something that's really nice here that they've done is that they've used this labeler. So if I scroll down, here's the labeler option in facet grid, and for all the options that are up here, those are, arguments, we can scroll down to the argument and get a description of how it works. Okay, and if you don't find enough information, you can usually dig down a little bit, like into the labeler, and learn more about how it works. Okay, in this case, is it obvious how it works? Because this says label both, and I didn't see a label both here, and I didn't see a label both up here, just a label value. So if we go into labeler, how do we know what both is? I think that both is the variable name and the category within the variable. I think that's what that means. As labelers. Okay. Anyway, left as an, so here's one that's like global labeler. Anyway, there looks like there are lots of things to learn about labeling. I'll leave it at that. Okay, but label both looks like a really nice option because it says metro, the metro variable level no, metro variable label yes. Okay, pop change gain, pop change no gain. Sometimes those labels might end up being too long in those cases, so you have to, then you can format your labels. Things can get pretty complicated quickly. Anyway, so I want to show you one more thing here. What if you wanted these to be rows to be combinations of pop change and metro? Well, you could put pop change plus metro as rows. Then we've got tilde, and then the columns are period. There's no variables on the columns. Okay, so here we've got then 4 rows. Metro no. So the first variable was pop change. So we've got pop change on the outside, gain for the top 2, and then the second level of the hierarchy is metro. So then we've got metro no, metro yes. And then down here we have pop change no gain, and then metro no and metro yes. So you can arrange your grid however you want, even by combining these variables. If we put them across columns, that's what it looks like across columns. Okay. That's the main thing I wanted to show you there. Okay, and you can do the same thing with those ridge plots. And that's the end. So I hope that that was instructive in the use of ggplot and tables and being able to investigate parts of the flow. So anyway, it was fun for me to go through this. I will make a similar video with the numeric data chapter 5, exploring numeric data.